Welcome back to another exciting day in Algebra 2. Today we are going to be talking about inequalities. So, an inequality with two variables means we have x and y in our inequality, and our solution, which is an ordered pair, x comma y, is a solution if the inequality is true after you substitute both your x and your y values into said inequality. So let's take a look at that. First, on this example 1, I'm looking at this inequality, 2x minus 3y is greater than or equal to negative 2. And I'm going to determine if each of these points is a possible solution. So on A, if x is 0 and y is 0, when I substitute that into my inequality, that's going to be 2 times 0 minus 3 times 0. Well, that's 0 minus 0, which is 0. And 0 is greater than or equal to 2, so yes, 0, 0 is a solution. Let's look at 2, 2. If x is 2 and y is 2, 2 times 2 minus 3 times 2. So that's going to be 4 minus 6, which is negative 2. Negative 2 is greater than or equal to negative 2, so yes, that is a solution. All right, last one. If x is 0 and y is 1, 2 times 0 minus 3 times 1. 0 minus 3 is negative 3. Negative 3 is not greater than or equal to negative 2, so this is not a solution. Okay, so that's solutions. Another way we can look at all of the possible solutions is with graphing, which you have done previously in Algebra 1. So to graph an inequality, we first want to rewrite our inequality in that slope-intercept form, meaning y is by itself. And then you plot your points. We used dashed lines for greater than and less than, solid lines when we have the or equal to, and then we shade above for greater than and below for less than. So that's something you've done previously, so let's practice that. Of course, we're going to have a word problem, meaning we need to write the inequality ourselves. So your budget requires you to earn at least $160 per week. You work 2 part-time jobs. The first job pays $10 an hour and the second job pays $8 an hour. Let x represent the number of hours worked at the first job and y represent the number of hours worked at the second job. So it's already defined our variables for us. So if x is the number of hours I work at my first job and I'm making $10 an hour, and y is the number of hours I'm working at my second job and I make $8 an hour, and I need at least $160 each week, that means the sum of those two jobs needs to be greater than or equal to 160. If I'm making more than 160, great, but I cannot make less than that, otherwise my budget is going to be off. So there's my inequality. Now I want to graph it and look at my solutions. So I want to rewrite this inequality getting y by itself. So first I'm going to move 10x over. And then I'm going to divide everything by 8. And so the inequality I'll be graphing is that y is greater than or equal to negative 5/4 x plus 20. So my intercept is 20, my y-intercept. My slope is negative 5/4. So I'm going to go down 5/4, down 5/4, down 5/4, down 5/4. And I'm going to connect those points with a solid line because I have that or equal to. And this inequality is greater than, so I'm going to shade above. So here are all my possible solutions, possible outcomes that will let me meet my budget requirements. So let's talk about a couple possible solutions. I just need to find an ordered pair in my shaded region. Well, one of those is 20, 1. 20 hours at my first job, 1 hour at my second job. Might be unlikely, but it's still a possible solution. Let's check it in our inequality. I'm going to plug this x and y value into my original inequality. 10 times 20 plus 8 times 1 needs to be greater than or equal to 160. Well, 208 is greater than 160, so that one does work. Let's identify one more. Let's look here, 16, 3. That's another point in my shaded region. And if I plug those values back into my original inequality, 160 plus 24 That's going to be 184. That is greater than or equal to 160, so that's another possible solution. And again, you could pick any other point in this shaded region and verify by plugging into your inequality that it is a solution. Okay, so this is all kind of review from Algebra 1. Let's take it a step further into Algebra 2. Sometimes we're going to have a system of inequalities, which means we have more than one. And so we see those in problems that have constraint statements like more than, less than, no more than, minimum, maximum. And so when we have two inequalities or more, a system, the solution, x, y, is only a solution if it is true for both inequalities. So you substitute the x and y values into both inequalities to see if it is true, and if it is, then it is a solution. So let's practice that. Here on A, I'm looking at the 2, 4, so x is 2, y is 4. Here are my two inequalities. I'm going to plug it into the top one first, and I'm just going to do it up here because I don't have a ton of room. So that's going to be 2 times 2 minus 4 is less than or equal to 5. Well, 2 times 2 is 4. 4 minus 4 is 0. And 0 is less than or equal to 5. Now I need to test it in my second inequality. It's going to be 2 plus 2 times 4 needs to be greater than or equal to 2. That's going to be 2 plus 8, which is 10. 2 is greater than 2. 10 is greater than 2, so yes, this is a solution. All right, now if I have x and y both being 0, if I plug it into my first inequality, 0 minus 0 is 0. 0 is less than 5. If I plug it into the bottom equation, 0 plus 0 is not greater than 2, so that one is not a possible solution. Look at the last one. If x is 0 and y is 1, it's going to be 0 minus 1, negative 1 is less than 5 for my first inequality. Then for my second inequality, 2 is greater than or equal to 2, so yes, that is a solution. Now graphing, we follow the same steps. We want the slope-intercept form. We do the same rules for solid dashed line, shading above and below, and then your solution set is where these graphs overlap. And so any point in the overlapping region is a solution. So let's practice this again with a word problem. Peyton and her children went into a restaurant where they sell drinks for $3 and tacos for $4. If Peyton has $40 to spend and must buy at least 10 drinks and tacos altogether, let's write our system of inequalities to represent this equation. Now, this one we were not given variables defined, so let's do that first. I'm going to let x be the number of drinks and y be the number of tacos. So the first inequality is going to come from our budget. How much money do we have available to us? Well, if drinks are $3 each and tacos are $4 each and I have $40 to spend, that means that the total should not be any more than $40. It can be less than $40, but it can't exceed $40. It can be equal to $40, but not bigger. So that's less than or equal to 40. And then if I need to buy at least 10 items, that means that my total of x and y, it can be more than 10, it can be equal to 10, but it can't be less than 10. So there are my two inequalities. If I'm going to graph them, I need to rewrite both of them in my slope-intercept form. So that first inequality will be y is less than or equal to negative 3/4 x plus 10. I do that by moving the x over, then dividing by 4. And then on the second one, I just need to move x over. So y is going to be greater than or equal to negative x plus 10. And now I'm ready to graph both of these. I am going to do the first one in yellow. So my y-intercept is at positive 10, and my slope is negative 3/4. So I'm going to go down 3 over 4, down 3 over 4, down 3 over 4. And again, this is going to be a solid line. And this is less than, so I am going to shade below. So there's my first one. I am going to graph the second one in pink. Again, my intercept is 10, and this time my slope is negative 1. So down 1 over 1 all the way through. This is a solid line. and it is greater than, so I'm going to be shading above. So my possible solution set is going to come out of where these two colors overlap, and I'm going to outline that in purple just so we can see clearly that it is this entire region here where the pink and the yellow overlap. So I can pick any point within that region, and I can check with my inequalities to see if that's a possible solution. So let's pick 2. I can see the point 10, 1 is inside. So 10, 1. And let's test that one out. I'm going to plug it into both inequalities, and I'm going to do it with my original one. So 3 times 10 plus 4 times 1 needs to be less than or equal to 40. Well, that's 30, that's 4. 34 is less than 40, so that works. Let's test it with the second inequality. 10 plus 1 is 11. 11 is greater than 10, so that one works. Let's identify one more solution. I see the point 8, 3 in that shaded region, so I'm going to test 8 and 3. So that's going to be 3 times 8 plus 4 times 3. That's 24, that's 12. 24 plus 12 is 36. 36 is less than 40, so that one works. Now let me test it in my second inequality. 8 plus 3 is also 11, and 11 is greater than 10. So those are both possible solutions. And again, there are more than that. You can take any ordered pair in that shaded region. The main difference between a system of inequalities and a system of equations is that we have multiple possible solutions. With a system of equations, you only have one solution. With inequalities, we have more than one. And that is it for our notes.